Okay, so we're going to continue on with our trigonometry unit today with a new lesson on cosine law, which is an extension on sine law to help us solve other different non-right triangles. Here we go. So we're going to learn about a new strategy. This is going to work for the triangles that sine law wouldn't otherwise have worked for. We'll do a few examples of cosine law plus a word problem just for fun, and we'll see how this goes. Here we go. So just a quick review of sine law here. Sine law, as you can see on the screen right now, is that. Both of them are on your formula sheet. The one on the left where you have your angles on the top are useful for when you're solving for an angle. But the one on the right where you have your side lengths on the top, that's useful for if you're looking for a missing side, length, right? Now the trick behind doing these was making a key. A key is just a known angle as well as the known side across from it, so you can complete one of the pieces, either this or this, in sine law. So in other words, you know you can do sine law when you know a side and you know an angle across from it, right? Because then that's going to form yourself a key. All right, so we're going to do a real quick example here. Solve for the measure of side length y. So we're looking for this one right here. First things first, find yourself a key. Oh, no, before you do that, make sure, since we're looking for a side length, we know we're going to be using the version of sine law that says the side lengths, of course, on the top. All right, so I'll just write that down. Good, there we go. All right, so now that we know we're using this, let's find ourselves a key. So let's look for a side length that's already known. Well, this one's already known. And an angle that's already known right across from it. Yep, that's already known. So we're good to go. We can make our key 7 over sine 60. That's going to be our key. We're looking for y, so we're going to say side y, divided by the sine of the angle across from it. And then that's where we run into a little bit of trouble here. Notice we don't know what that angle is across from here, so it's like we have a double unknown. So usually you'd think we'd be hooped on this one, but good news is we're actually not. Notice we know the other two angles in this triangle. In a triangle, the angles will always add up, so including this capital Y, the angles will always add up to 180 degrees. So if we subtract these other two angles over, we can solve for what y is going to be. I'm going to start by subtracting 80 over, so this is going to give me 60 plus capital Y equals 100. And then I'll subtract 60 over, so capital Y is going to equal 40 degrees. So we know this is 40 degrees. Let's throw this into our sine law now. So we have y over sine of 40. And then to solve for this side length y, we just need a times by sine 40 on both sides. So we can throw this in our calculator all in one big swoop. So 7 times sine 40, and then divide that by sine of 60. And you're going to get, let's say, just the nearest tenth, y is equal to 5.2. There we go. So that would be the length of this side y. And there's no units on this. Like if it was 7 feet, would be good, but we don't have units on it, so it doesn't really matter. All right, here's the next example. Can we use sine law to solve for the missing measure, or the measure of side length A in this triangle? So we're looking for this side length right here. Since we're looking for a side length, we'll use the sine law that has the side lengths on the top. Let's start by finding ourselves a key. Well, if you look at this, we know the other two sides, so 3 feet and 7 feet, but notice we don't know the angles across from either of those. That's kind of what throws us through a loop here. We can't make a key, so in other words, we can't use sine law. So can we use sine law? No, because we can't. There we go, can't make a key. There we go. Since we can't make a key, we can't use sine law. We're totally out of luck on this one. I guess we just have to give up and go home. Nope, we're not going to give up and go home. We got cosine law. Cosine law is actually going to help us on this one. So when we can't create a key, we need a new tool. And this new tool is called cosine law. It's also in your formula sheet, and it's a lot bulkier than what sine law was. This is where it's super important you understand that capital letters and lowercase letters of the same type of letter are just across from each other, because that's what really is what makes a big difference on this one. So this one here where we have a squared all by itself, that's what you use if you're looking for a missing side A. And then this one where it's just cosine capital A on its own, that's when you're looking for a missing angle capital A, right? And that's what it kind of just says here before. The top one where a squared by itself is used for solving for a missing side length, whereas the bottom one where cosine A is by itself is used for solving for a missing angle, okay? It'll make a lot more sense once we start seeing some questions with this. Let's just do the one that we just did before. So here we go. Now we can solve for the missing side length A here, whether you believe me or not. And again, this is on your formula sheet. I have a formula sheet right in front of me right now. It's not like I can memorize this. I'm not that great at this or anything, right? I need the formula sheet so I can see what the formulas are. We're looking for this side length right here. So side length lowercase a, that would mean that this angle of 27 degrees up here is technically your capital A because they're across from each other. Now, you might be wondering which one's B and which one's C. Well, the good news is with cosine law, it doesn't matter which one's B and C. They're interchangeable. So how about we just say that this side is lowercase b, which means that this angle down here is capital B. And we can say this other side is side C, which means this angle down here is capital C. Not like those other two angles are going to matter at all here. Now, since we're looking for a missing side length, let's use the version of cosine law that has the side length on its own. That's the one that says a squared equals, and again, I'm looking at my formula sheet right now, equals b squared plus c squared minus 2bc cos a. Now, this 2bc cos a, really this means 2 times b times c times cos a. So you'll often see me put like a little dot between these two c's so that the c's don't get stuck together. This is cosine a in here, right? So it's 2 times b times c times cosine a in this whole section right here. So let's just throw the numbers in. We don't know what lowercase a is. That's what we're looking for. So let's start by saying a squared equals b squared, so 3 squared, plus c squared, which is 7 squared, minus 2 times b, so times 3, times c, so times 7, and then times cosine capital A, and capital A was 27 degrees. Now, it depends on how comfortable you are with your calculator. If you're really comfortable with your calculator, you could throw this in all in one step, or you can take like little bites out of it one bit at a time. Personally, I'm just going to take this one little bite at a time here, so I'm just going to solve each of these little individual pieces first. A squared is going to equal 3 squared, which is 9, plus 7 squared is 49, minus 2 times 3 is 6, 6 times 7 is 42, so minus 42 times cosine 27. Then I guess the next thing we could do, I think we could just stitch this all together in one go. This is going to be a squared equals, let me just pick up my calculator here, 9 plus 49 plus, minus 42 times cos 27. And remember, make sure this is stuck together because technically using BEDMAS, remember BEDMAS from I think math 9 or so, division and multiplication have to come before addition and subtraction. So technically this piece gets done first. 42 times cos 27. Anyway, throwing this all in your calculator all at once, you might even want to try this right now. You can pause the video here if you need. But what this whole side should equal is 20.5777. Now that is not the measure of of side length A. You have to square root both sides to get that done. So if you square root both sides here, you're going to see that lowercase a is therefore going to equal, and we'll just say the nearest tenth, 4.5. And I guess technically the units, because we gotta match the units here, it's 4.5 feet. Whew. So cosine law, clearly a lot more beefy than sine law is, but as long as you keep track of what angles and what sides you have, it's not too terribly bad. Let's do another one here. Solve for the missing side x. This is what's really weird. Again, we're looking for a side x. So remember the formula is a squared equals b squared plus c squared minus 2bc cos a. Since we're looking for x, x is going to serve as our a. So I'll kind of put in quotations here. This is our a, which means 17 degrees up here across from the x. That's our capital A. We can therefore say that this 40 kilometers is B and 35 kilometers is C. You could do it interchangeably. It doesn't matter which one's B and which one's C as long as you just have them in there. And yeah, so that's where we're going with it. So x is our A. Okay, so instead of saying lowercase a, I'm going to say x in this one. So I'll say x squared equals b squared, so 40 squared, plus c squared, so plus 35 squared, minus 2 times b, so 2 times 40 times 35, and then times cosine a, so cosine 17. This a has to be the angle across from the missing side. That's the whole idea here. I am going to just rush this one. I'm going to throw this all in my calculator all in one go. You might want to try this as well because, again, throwing it all in your calculator in one go can be tricky for some people. So just make sure you're getting it right. 40 squared plus 35 squared minus, and then you know what really helps actually, just to tell you right now, maybe put another set of brackets around this whole multiplication chunk. That's a 17, by the way. If you put another set of brackets around that, that's going to keep it safe. So I'm going to put a set of brackets around there after I hit minus. So minus 2 times 40 times 35 times cosine 17. And that gives me 147.5 3466. That's equal to x squared. Now we just need to square root both sides to get rid of that squared. So x is therefore going to equal the square root of that, and that's going to be just the nearest tenth, 12.1, and I guess the units on that are kilometers. So again, make sure you list your side lengths out in terms of A, B, and C, and capital A for the angle across from the side that you're missing, and you'll be just fine as long as you just take care of those, and it's just a matter of throwing it in your calculator. The formula is on your formula sheet. You are going to need to rely on that formula sheet quite a lot here. All right, next one, solve for angle J. This time we're looking for an angle. Since we're looking for an angle, we're going to use the other version of cosine law, the one that says cosine A equals b squared plus c squared minus a squared, all divided by 2 times b times c. Now here's what's weird about this one. Angle J is technically, and I'll put it in quotations, that's going to be our quote-unquote capital A. If this is our capital A, then that means this 10 meters over here is our lowercase a. And then remember, B and C are interchangeable. It doesn't matter which one's which. How about I say this one, the 17 meters is B, and this one, the 11 meters is C. Again, you can interchange them. It doesn't really matter which one's B and which one's C. The only ones that really matter are capital A and lowercase a. Those are the ones that have to be placed correctly. B and C are interchangeable. All right, so let's throw this all in. Instead of writing A, I'm going to write J because that's really the name of the angle we're looking for. So cosine J is going to equal B squared. So according to how I've labeled this triangle now, that's going to be 17 squared plus C squared, so that'd be 11 squared, minus A squared, so 10 squared, all divided by 2 times B, so times 17, times C, which is 11. Now on these questions, just to be really safe, I would calculate the numerator, so the top of the fraction first, and then calculate the denominator, and then worry about taking the inverse cosine. Because again, to find angle J, we'll have to take the inverse cosine of whatever this fraction is here. So just to be safe here, I am going to break this one down. Cosine J, that's going to stay the same. On the numerator, I got 17 squared plus 11 squared minus 10 squared. And that's actually, surprisingly, quite a nice number, actually, 310. And then on the bottom, we got 2 times 17 times 11, which is 374. To solve for J, let's just take the inverse cosine of this. So I'll say J is equal to the inverse cosine of 310 divided by 374. So that means we've got inverse cosine, just throwing this in my calculator now, 310 divided by 374. And please make sure you're giving this a try on your own as well, because again, it can be finicky. J is going to equal to the nearest tenth, 34.0 degrees. So cosine law works that way as well. Okay, we're going to move on. One last one here. This is a word problem. With word problems, just by the way, make sure you're drawing a picture of the scenario. So here we go. A laser distance measurer tells you how far away something is from you. Standing on the shore, you measure the distance to one yacht as being 230 meters and another yacht as 540 meters. From your perspective, the angle between the yachts is 25 degrees. How far apart are the yachts? So in other words, we're looking for how far apart directly from the first yacht to the second yacht. So even though you're not out there and you can't directly see how far apart these two yachts are, standing on the shore, like imagining this photo was you standing on the shore taking this picture, you could measure that the distance to this from your laser measurer was 230 meters. And the distance to this far one, oh, that wasn't a very straight line. Let me erase that. Let's try that again. This far one, there you go. That's going to be 540 meters. If you therefore think of a line that connects the far one to the near one, that would tell you how far apart they are. So how about I call that X? We know this one is 540, and this one is 230. And then something else that's quite interesting is we know the angle from your perspective, you're standing right here at the bottom of the triangle. The angle in between those two yachts is 25 degrees. Well, this is a cosine law question again as well, because we have a missing side. We can't make an opposite key pair like we would for sine law. So that kind of narrows it down. Since we're looking for a missing side, we're going to use that version of cosine law that says a squared equals b squared plus c squared minus 2 times b times c times cosine a. So the 25 degrees is your capital A, x is your quote-unquote lowercase a, and then the other two can be b and c. Again, they're interchangeable. It doesn't matter which one's which. Throwing these numbers in here, we'll say x squared equals b squared, so 540 squared, plus c squared, so 230 squared, minus 2 times b, so times 540, times c, so times 230, and then times cosine of your angle, so times 25. This is really intimidating looking when you start throwing numbers in here, but just as long as you're following it through and just throwing the numbers right in your calculator, you should be just fine. I'm going to throw this in my calculator all in one go. Remember this whole multiplication chunk in here, put brackets around here. And another thing that sometimes I see people forget, sometimes people forget to square these. Make sure you're squaring everything. So here's what we got. X squared equals, let me throw this in my calculator, 540 squared plus 230 squared minus, and then I'll put brackets around the whole thing, 2 times 540 times 230 times cosine 25. Close all those brackets off. Holy smokes, we get a big number, 119,373.147. Wow, okay, now we just need to square root this, of course. So square root those, square root both sides here, so square root this and square root this. You're gonna find x, the distance between the two yachts, and we'll just do the nearest tenth, is 345.5, and we'll match the units, it'll be meters. Wow. Wow, okay, yeah, that was quite a lot here today. I know it's probably pretty overwhelming, but don't worry, we're gonna spend a couple more days on this. For practice, make sure you're just finishing off the rest of that booklet, page 276 to 286. And as always, if you need any help, make sure you're reaching out. Best of luck.